Okay, so in this video, just basically going to talk about like the chain rule and stuff like that. So maybe let's start with a simple example. Let's say that y equals 2x minus 5 square. And we say find the derivative of that function. Now I know what you're thinking. You're probably going to say, okay, I can simplify y, expand that, and I'm just going to have 4x squared, 2 by minus 5, that's minus 10, multiply that by 2, and then you get something like it's minus 20x, and minus 5 squared, that's going to be 25. And then from then you can take the derivative of that function, dy dx, or just y prime. You can use the prime notation, it's fine. So y prime equals 8x minus 20. So that's the derivative of that function. And now if you were asked to find a tangent at some certain point, then you know that the derivative at that point will technically give you the slope of that function, of a tangent at that point. So now what about this function then? Let's say we have y equals 3x minus 2 to the power of 3. Well, you can be a patient person and say, okay, I can just expand that. I can just expand that and like work throughout that. Or if, the key size idea here is that you just have to be smart with these things. One of you can decide to like expand this, and the other person can be just like, let me do this instead. Expanding something to a cubic thing can be complicated, and most of you, I doubt that like will want to like expand the cubic thing here. But then one of you can just say, okay, I have y equals 3x minus 2, multiply that by 3x minus 2, multiply that by 3x minus 2, and then you can use the product rule on 3 functions. This is just, be idealistic with these things. So I think that's pretty cool though, because like it's being idealistic. Okay, let's look at 3 functions. This is a product rule of 2 functions, a and b. So you have a prime b plus a multiplied by b prime. And if you have 3 functions, it's just the same thing. You have 3 functions a, b, c. So that means that you'll have a prime multiplied by the other 2 functions plus a multiplied by b prime times c, and then plus, and then you just have ab multiplied by c prime. So you derive one function and multiply with the other functions, derive the second function, multiply with the other 2, then derive the third function, multiply by the first 2. So it's just the product rule. Then you can just apply that there, or you can just expand. It depends. But expansion of a cubic thing, I'm pretty much lazy to do that, but using this is kind of like idealistic. Then you have y prime equals, then if I'm going to use this, you have 3 functions that they're identical. So that means that I'm just going to derive this one. The derivative of 3x minus 2, that's just going to be 3. And if you look at these 2 functions, they're identical. That's b and c. So you're just going to multiply these 2 and notice that you just have 3x minus 2 squared. Plus, you keep the first function the same, but notice that this first function and the last function, they're basically the same thing. So you're just going to have like 3x minus 2 square again, and then you derive the middle function. It's just the same as others, then you just have 3. You keep repeating the same process, and then you multiply the first 2 functions, which is this, and they're identical. Then you just have 3x minus 2 square, and then you multiply that with the derivative of the last function, which is just 3 in this case. Notice that you can just pick up the terms here. These are identical terms. So you have 3 multiply by this plus 3 multiply by this. So then you can just add them because these are like terms. So you have 3 plus 3 plus 3, that's just going to give you 9. So that just says that y prime equals 9 into 3x minus 2 squared. How cool is that? But now notice something here. If you look, the thing is like we have to come up with a pattern here of what's happening here. And then we can do the same process. Maybe if we say we have y equals 4x minus 1 to the power of 4, and now the product rule of 4 functions, then it's just going to be a little bit complicated. Now we don't want to do that forever though. Now I'm going to introduce you to something called the chain rule. So it's basically like it deals with compositions. So we look at a function and say, okay, this was going to be easy if I was deriving x to the 4th. I know that if I take d over dx of x to the 4th, then I can easily derive that. I'm just going to have 4x cubed. So what technique can we use here? Also here and also there, that can like simplify this whole thing. So I'm going to introduce you to the chain rule. The idea is like you look at how many functions you have. So if you have 2 functions, that means that you'll have dy dx being something like dy du, multiply that by du dx. What does this mean? So this means take the derivative of the outside function irrespective of what's inside. Irrespective of what's inside. Take the derivative of the outside function irrespective of what's inside. Multiply that by the derivative of what's inside. So this is when you have two functions. You have a composition of two functions. Or you just have one function's composed with another. So you just have maybe f evaluated at g at x, or stuff like that, where we're just gonna let our g at x be u in that case. But if you have three functions, you can do the same process again. Then you have dy dx equals dy du over du dk. Multiply that by dk dx. That's when you have three functions. The derivative of the outside function irrespective of what's inside. Multiply that by the derivative of the middle function irrespective of what's inside. Multiply by the innermost function, by the derivative of the innermost function. You can do that. This is when you have three functions. This is a chain rule if you have three functions, and then you have stuff like this. So now, if you have four functions, you can repeat the same process. Then you're just gonna have dy dx dy dx being something like dy du by du dk, and then by dk dt, or dm, and then you have dm dx. That's when you have like four functions. So you can repeat the same process for n functions. You can have the chain rule for the n functions, but let me just start the chain rule of two functions. Okay, so I said that you derive the outside function irrespective of what's inside, and then you derive the inner function. So let's look at this function. Now I want to derive this using the chain rule. I don't want to expand that. I'm lazy. So now that you have y equals 2x minus 5 squared, so that means that you'll have y prime being equals to dy du. I said you derive the outside functions irrespective of what's inside. So that means you'll treat 2x minus 5 as one thing. You treat 2x minus 5 as one thing, and then you're just going to use the power rule to derive that. What does the power rule say? You're just going to take the 2 there and then subtract 1 from the exponent. So 2 minus 1, that's 1. Anything to the power of 1, you don't really need to write that 1, but it's technically 1 there. And then again, you derive the innermost function. So the inner function, like, that's going to be the derivative of this one. Then the derivative of the inside is technically going to be 2. Simplify that, then you have 2 by 2, that's 4. Then you have 4 into 2x minus 5. And then you're just going to have 4 by 2, and then that's going to be 8x. And then 4 by minus 5, that's minus 20. So same answer. And then if you have this one, then it's also two functions. You have the inner function and the cubed function on the outside. So it's a chain rule of two functions also. So that means that you're just going to have like, if you have y equals 3x minus 2 cubed. So remember I said derive the outer function irrespective of what's inside. So you're just going to treat this one as one variable. Then you derive the outside. Then you're going to use the power rule. Then you have 3 into 3x minus 2, then you subtract 1 from the exponent, then you have square. And then it also says derive the inside. So when you derive the inside part, then that just means you're going to have 3 there. Notice that 3 by 3, that's just going to give you 9. And then you have 3x minus 2 square. So that will be the derivative of that, which is the same as that. But notice here I didn't expand. I decided to use the product rule instead. But what I'm showing you is that there's a pattern in these things. Just become strategic with these things. And here you don't want to use that product rule 4 times. So then that means that you can just derive that using the chain rule, and then you can try this. Try this, and you can pause the video, try that, and see if you can work it out. Okay. So I'm just going to write the answer there. Then you have y prime equals 16 into 4x minus 1 cubed. That will be the solution to that. Did you get the same thing? Hopefully you did. So you can have a chain rule of 3 functions. You can have a chain rule of 4 functions. But let me just give you an example of 3 function chain rule. So let's say maybe you have sine of x squared. Okay. Now let's say y equals sine square of x squared. So if you have sine square of x squared, then that means that you have something like this. And now how many functions are there? If you say 2, well, you're wrong, but technically you're wrong. But it's easier to like rewrite this thing like this when you have like sine of x squared, and all of that is technically squared. Notice that you can take the outermost functions as the square function here. And you can take the inner function, the middle function, as sine. the middle function is sine, and the innermost function is just going to be x squared. So that means you have like 3 functions there. So that means you're going to use something like this. What does that say? So if you want y prime there, that means you derive the outside function irrespective of what's inside. So we disregard this, we treat this as one thing, then we derive. So you're just going to take the 2 outside, it's a power rule, and then we take the 2 outside, and then we subtract 1 from the exponent in that case. Then that means that we have something like this. Since it's to the power 1, we don't necessarily need to write that 1. Then you have something like this, and you also derive the middle function. The middle function is sine. What's the derivative of sine? The derivative of sine is cosine. So you just have cosine x squared. You disregard what's inside, technically. So you disregard this x squared. And then you derive the innermost function. What the derivative of the innermost function? The innermost function is x squared. So you take the derivative of x squared. That means that you're just going to have 2x. So you can rewrite that properly, and then you just kind of have 4x. If you multiply 2 by 2x, then you have 4x. Multiply that by cosine x squared. Multiply that by sine of x squared as well. But then if you know your mathematics, then you don't necessarily need to write something like this. You can also have 2 there. Then we know that this notation here is just going to be sine of 2, the angle. Remember sine 2 theta? Sine 2 theta is technically going to be 2 sine theta. Sorry, 2 sine, okay, let me rewrite that. Sine 2 theta is going to be equals to 2 sine theta cosine theta. So that means that you're technically going to double this angle and take away these 2. So one way you can write it for 4x by this one, but then you can just use this one as sine 2 of that. Then you're just going to have 2x sine of 2x squared. So that's one way to rewrite that solution. So that's a chain rule of 3 functions. You can also try a chain rule of 4 functions. So it's technically not a big deal, really. It's not that much of a big deal. So that's that. So hopefully like you find this video helpful, and you can try more problems with the chain rule and see if you get hang of the things. And if you don't understand the things, there's a quick way I've shown in one of my earlier uploads, where I show you how you can like master derivatives in like 10 minutes. You can check that out as well.